In this lesson, we will learn about the pendulum. So we'll start off by describing what periodic motion is. So when we say something is periodic, we mean it repeats itself. So for example, you have class period. We call this period 3, for example, or period 5. We call it a period because it is a class session that repeats itself over and over and over again. The time it takes to complete a cycle and start over is called the period in physics. And there's lots of examples of this. For example, the Earth goes around the Sun. It takes 365 days, and so we say the period of the Earth's orbit is 365 days. After 365 days, it starts again. It's not exactly 365 days, so every once in a while we got to add an extra day here and there, but it's close. Fertility cycles are commonly experienced by female mammals, and the time it takes a cycle to complete is called the period. It's usually about 28 days. So that's another example of how we use the word. A pendulum that swings back and forth has a period. It has a characteristic time that it takes to complete its motion and start another cycle. And if we take a mass, we put it on a spring and give it a little bump, it bounces up and down, so it has a period. And ocean waves are periodic. They repeat over and over and over again. And the time it takes from the top of one wave till the next top wave rolls in is the period of the ocean wave. So the period of a system is the time it takes for the motion to repeat itself. We are going to use the variable t to represent the period because it's really a time. And so we use t for time, and it's a special time, so we use capital T. So t is the period that is measured in seconds. All right? So in lab, you guys explored how the period of a pendulum depended on the length, and you got a graph that looked like a parabola opening on its side. So you probably squared the length on the x-axis, took the square root of the length on the x-axis and got a straight line, which tells us that the period, and we should use t here, the period is equal to the slope, 2.01, times what's on the x-axis, which is the square root of the length. You also found in lab that the period does not depend on the mass. As you made the mass bigger and bigger and bigger and bigger, the period stayed constant. It did not change, so it doesn't depend on the mass. And the period also doesn't depend on the amplitude. It doesn't depend on the size of the swing. So those are all things we found in lab. So we found that the period is proportional to the square root of the length, and it does not depend on the mass, and it does not depend on the amplitude or the angle that it swings. So we actually got this math model, and if you were in class, we would actually test this math model. We would see if it works. We got a big pendulum that hangs in the middle of the classroom, and we would measure it. We would take its length, which is 2.5 meters, and we'd plug it in here and calculate the period, and then we would swing it and see if it actually worked. And it turns out it does work. So our math model works. We can also ask, how does gravity affect the period of a pendulum? And there's a link here you can go and play with if you want. The short story is that the gravity is inversely proportional to the period, the strength of gravity. So the final equation, when we put it all together, looks like this. And if you want to know where does that come from, we can actually derive it in AP Physics. But for this year, we are just going to state this equation. So this is how we find the period of a pendulum. The period is 2 pi, that's a constant, times the square root of L over G. And since G is 9.81 meters per second squared, we have to use meters for lengths, and we have to use seconds for the time. That's why the period is in seconds and the length is in meters, because our constant is 9.81 meters per second squared. Okay, so that should be in your toolbox. Check and make sure it's there. We're going to use this equation a lot. All right, so here's our first example. We want to calculate the period of a pendulum that has a mass of 12 kilograms and a length of 2.5 meters. So this is a diagram. It's just a simple little diagram showing a pendulum. Write down what you know. You know the length, you know G because it's on Earth, and you know the mass. And then we're just going to simply evaluate this equation. T equals 2 pi square root of L over G. Plug in L and G, run this through your calculator, and you should be able to get the result 3.17. I highly recommend stopping the video and making sure that you actually get that. Make sure your computations are working out. So that's how we find the period of a pendulum. Now, there's a related idea to period, and that's frequency. So if period tells us how long it takes to complete a cycle, and we measure it in seconds, then frequency tells us how many cycles happen in 1 second. We measure frequency in cycles per second, which is also known as a hertz. That's H-E-R-T-Z. So 1 hertz is a cycle per second. So to kind of help you figure out this, let's do a little thought experiment. Suppose I have a pendulum and the period is 0.2 seconds. So that means it repeats its motion every 0.2 seconds. How many oscillations or cycles will there be in 1 whole second if it takes 0.2 seconds for 1? Well, I think you can figure out you would get 5 cycles in a second. So 1 cycle is 0.2 seconds, 2 cycles will be 0.4, 3 cycles would be 0.6, 4 cycles would be 0.8, and you'd do 5 cycles in a whole second. So these numbers are related. If the period was half a second, then you would have 2 cycles per second. And if the period was 3 seconds, you would have 1/3 of a cycle every second. So I think you can tell that these numbers are reciprocals. So if the period is 3, the frequency is 1/3, or 1/3. If the period is 0.5, or 1/2, then the frequency is the reciprocal, which is 2. So this is another equation in your toolbox, and anytime you have the period, you can find the frequency, and if you have the frequency, you can find the period. They are simply reciprocals. So remember, the period is the time, measured in seconds. The frequency is the number of cycles per second, and it's measured in hertz. So here's an example of how we might use that. We have a tiny little pendulum, and it's 1 centimeter long. We want to know what is the period and the frequency of this pendulum. So we've got a diagram. We write down what we know. We know the length. We know g because we're on Earth. And the length is in centimeters, so we divide by 100 to get meters. We've got to make sure we do the conversion. We're going to plug in those numbers, 2 pi square root of L over g, to find the period. That tells us t, the period, which turns out to be 0.201 seconds. Once we know the period, the frequency is 1 over the period. So if you take 1 divided by 0.201, you get 5. So the frequency of this pendulum is 5 hertz. That means it makes 5 complete swings every second. All right? So that's the idea. Sometimes we give you the frequency, and you'll need to find the period. You can't solve this equation without the period. So if we tell you the frequency, take 1 over the frequency to find the period. One last thing, sometimes we got to solve this equation for G or for L, which are inside the radical. And so here's just a little bit of help getting there. If you square both sides of this equation, you're going to get t squared on the left side. So there's t squared. If you square 2, you're going to get 4. You square pi, you're going to get pi squared. And if you square a square root, you just get L over g. Now, I'm going to multiply both sides by g. So the next step is to multiply both sides by g. So I'm going to get g times t squared equals 4 pi squared L. And once you're here, you're home free. Because if you want to find L, divide both sides by 4 pi squared. If you want to find g, divide both sides by t squared. So once you get to this stage right here, it's pretty easy to solve for either g or L. So in some of the homework problems, you'll have to do that. So that's the lecture in short. And so you can use that to kind of figure out how to solve the problems which are online.